Hello everyone and welcome to our webinar. This is Sydney speaking, and as you all know, today's webinar we'll be talking about the power of pocket recognition. Now before we continue, let me just remind everyone that at the end of the webinar you'll be able to ask questions. If you have a question, all you have to do is just click on where it says raise hand, write your question down in the questions area, and after you finish writing down the question, make sure you click on the send button as shown over here, and then I'll be able to see the questions and answer them at the end of the webinar. Okay, so let's get started. One moment, please. I didn't show my screen. Okay, now, as I said, the webinar is on pocket recognition. Now, what I'm going to do is basically, I'm going to be showing this to you on two different parts. The webinar, by the way, is not a long webinar. It's about half hour, 35 minutes long, this webinar. And I'll be showing it to you on, as I said, two parts. One is the part that you see on the screen. It's not a small part, but it's not that big of a part either as well. It's approximately, let's say, 260 millimeters by 200 millimeters. And another part that we have, however, I'll show that to you in a moment, is actually a much smaller part. This part, if we take a look at it, and we'll show it without the stock or the fixture, is actually a much smaller part where we have actually very small channels and pockets where we actually have to use very small end mills as well. So we'll go through both parts as shown over here. Okay, so we'll start with our first part that I wanted to show you. And if we look at the part to analyze it, just a moment, okay. If we try to analyze the part, we'll see that we have many different types of pockets here. First of all, we have this huge pocket inside over here, as well as smaller pockets up until that level. We have actually, this is considered also a step over there. That's also a pocket up until that level. We have a pocket down here. We have a pocket up until this level over here. We have this area over here. This surface over here is also a pocket, which is actually open on both ends. And even this surface over here is also going to be machined out in the pocket recognition, because this surface is actually lower than the very top of the part itself. So let's get started. One more thing I didn't mention is also I want you to note that in this particular part, there are also two other elements we should pay attention to. One is that we have a radius at the bottom of this boss over here of 1 millimeter fillet. We have a 1 millimeter fillet radius over there. And in this area over here, along this wall, we have a 2 millimeter fillet as well. And we'll see exactly how we deal with that inside pocket recognition. Okay, so we'll start with going to our recognition operations, and we'll choose the option of pocket recognition as shown over here. Now, just a quick reminder, this webinar is also being recorded, so you'll be able to see this on our website probably sometime tomorrow as well. Okay, now, note when I open up the pocket recognition, we have, just like any other pocket operation, looks very similar to our regular pocket operation. We have the choosing of the geometry, tool, levels. If I go into my technology itself, you'll see that the technology that we actually use here is just like any other pocket operation. Okay, so let's start with our geometry. Now, choosing our geometry in this particular case is a little different. If I go into creating a new geometry, you'll note we do not create a chain. Instead, there are three different ways of selecting our geometries. One is by selecting the entire solid body. 2 is by either choosing individual faces, or 3, choosing a through pocket chain. And I'll explain this a little later on as we go through the part. Now, what I'd like to do is take the entire part. Now, before I do that, we also have a filter over here. This filter, minimum diameter, allows us to control holes. What do I mean by holes? A hole, as far as the pocket recognition goes, is also considered a pocket. It's a pocket just like any other area, just like any other pocket. Now, however, there are holes here that we may not want to deal with. We don't want to have that go into the pocket recognition. For example, if I were to zoom into this area, we have this area down over here where we have small holes where we don't really want to have that as to be recognized as a pocket at all. So, but however, this hole over here, I do want to recognize as a pocket. This is a larger hole. So if I put my cursor over here and click on this edge, you'll see that is the minimum diameter that we have over here. So anything that's that or smaller will not be recognized. Since I do want to recognize this, I'll make this a touch smaller than what it is over here, say 19 millimeters. And now I want to choose my solid body. By choosing the solid body, all I have to do is click on the part itself, and you note that it's actually going over the entire body and picking out every single face that's on that body itself. If I go down the list over here, you can see every single face is chosen, and you'll also note that next to every single face, it also recognizes what the depth of that particular pocket is. You can see over here it's 15 millimeters. Here we have a depth of 16 millimeters. Over here we have one of 21 millimeters. And going further down on the part over there as well, 23 millimeters. We have all different types of depths on the part itself. You'll also note that one of these elements over here is what we call a chain. The chain is actually where we have a pocket that has no bottom to it as well. So there is no surface to be picked over there. Instead, it picks up automatically the very bottom chain, and by picking the bottom chain of that, it also calculates what's the depth of that as well. Okay, that's all I need to deal with right now at this moment. We'll accept that. Next, we'll choose our tool. Let's go into our tools, and in this particular case, I'm just going to choose a tool that I have here, a 6mm end mill. And when we go into our levels, you'll note one thing that we don't have here, which we have always in our regular pocket operation. We don't have the pocket depth. That's because the depth, as I said, is automatically taken from the surfaces of each pocket, each individual pocket. It's calculated automatically. So we don't have a depth here at all. Now, if I go into my technology, our technology, as I mentioned before, is exactly like a regular pocket operation. And note, since it recognizes that there are open pockets here, it gives us the tab of open pocket as well. And I can manage that just like I manage any other open pocket, whether you use profile strategy, approach from the outside, everything is there. Let's just do a quick simulation of what we have over here. And we'll do this using Solid Verify. Excuse me for a moment. There we go. If I run it, you'll see that it actually machined every single edge that was over here from the very beginning until the very end. Now, also approaching these areas from the outside. Now, remember I had mentioned to you that on this part, we have two areas that have fillets on it. We had an area over here and an area over here as well that had fillets on it. This one being a 2mm radius fillet, and this one being a 1mm radius fillet. Let's take a zoom in at the simulation that was done over here, And you can see that in the areas of the fillet, it automatically created a step with the tool, leaving room exactly for the later on when we use a radius end mill, bullnose end mill to clear this area away, and leaving the material to be taken off over there. We have it over here as well as this area over here. We have that step. Now, looking at it honestly, it really looks great, but with one little problem that I don't really like. When I have these types of radios, the way I like to work personally is to actually have more than just one step. I like to break it down into smaller steps, this way leaving less material for the bullnose end mill to work over there, making it a lot easier for it to clear away the material. And it's especially true when you have the larger radiuses as shown over here. So let's see how we can deal with that. Okay. Well, we'll go back to our geometry. And in geometry, after we've created it, we also have an option here called Modify. If I click on Modify, you'll note that first of all, you have all the faces over here, and if there's one that I don't want to use, I can just take off the check mark for here saying that I don't want to do that one. But let's leave that alone for now. That's not what I want to do right now. What I want to deal with is this area over here, the fillets. Now, note that it's broken up right now, divide floor fillets to steps, which it did. But underneath that, we have the option of number of steps. If I click on number of steps, it opens up a dialog box. Now remember, I said there were two different radiuses in the part. There's a 1 millimeter radius and a 2 millimeter radius. At the very top of this window, it shows us automatically what's the largest fillet that we have, the maximum fillet radius that we have on the part, and it shows it at 2 millimeters. So automatically, it gives us this window over here, saying that any radius between 0 and 2, I want you to do that in one step. Now, I actually want to break this down and give this two different types of steps, one for the 2 millimeter radius and one for the 1 millimeter radius. So if I go down to the next line, I can actually open up this field and note what happens. When I open it up, the 2 actually jumps down to over here, and in the first line, it automatically splits it to half the distance. Now, if I can also change it if I want to, say to 0.75, and note that this line will continue from that point on. I can do whatever I want over here, have it in any way. Let's just leave it at 1 millimeter for now. So anything between 0 and 1, this is the number of steps it's going to do it in. Let's change this actually. I like to do it, say, in 2 steps. And anything between 1 and 2 millimeters, I want to do that, say, in 3 steps. Okay, now that I've accepted it, let's take a look at our simulation. And you'll see, as I zoom in to this area, we have here on the 1 millimeter radius, it's broken into 2 steps. Of course, if I wanted, I could have done even more. Now, if we go into the area where we had the 2 millimeter radius, such as over here, you can see this is broken down now into 3 steps. And I can actually manipulate it any way I really want to. Okay. Now, one more thing, however, let me go back into the simulation and run it again from the very beginning. I want you to take a look at one more area. Note this area over here. The tool was not able to go through this entire slot over here because there was not enough room for the tool to fit in there. So for that, we have to use the option of rest. Let's go back into the operation now, and we'll just do save and copy. use the same geometry. We'll just change our tool to a smaller end mill. I'll use a 3mm end mill. And when we go into my technology field, we're going to activate the option of rest material chamfer to rest. Note the moment I do that, we have the tab over here of rest open up, and it jumps into that tab automatically. So I'm going to just put the value that I need over here. The previous tool diameter was 3mm. Okay. Previous tool diameter must be greater than the diameter I'm using. Okay. Here's right. I forgot to change. Sorry. In my technology field, the rest has to be 6mm. That was my previous end mill. Okay. Just checking to see if you're awake. Okay. Simulate. Now, if I run my simulation, you'll note that the tool will only work in this area. That's the only area that it worked in. No other place. Okay, so now let's go back to the first operation that I created over here. And I want to make a few changes. I want to create a new geometry. But this time, I want to show how this works, the face and the through pocket chain. Let's first start with faces. Let's say I only want to machine specific faces. For example, I'll choose the option of face. And I want to machine this surface over here. Note it adds it to this list over here. I want to machine this surface over there. Let's even take this surface as well as this surface, even this surface over here as well. Those are the surfaces I'd like to machine. Okay, we'll leave it exactly the way it is. We'll run our simulation. And actually, let's run our simulation this time using HostCAD, where we use the option of solid verification in HostCAD. Let's get rid of the toolpath. And let's actually take a look at what's going on over here. You'll note the following. This surface that I chose, even though we had a deeper pocket over here, so it recognizes that. However, it went directly over to flatten out that area. It recognized that this area was open and just cleared that entire surface over here. Whereas these areas, it recognizes them as an island as well. Note the same happened over here. When it machined this surface, the hole that we had over there, I did not choose to machine over there, so it actually machined that as a flat area over there. Okay, really, that's not bad. Actually, I'm pretty impressed with that. Now, let's go back into choosing our geometry. Let's do a little edit and make some changes. I want to add some more areas. For example, I'll go back to faces. Okay, I want to add, for example, this surface over there, as well as just let's say this surface over here. And let's say I want to add this hole here as well. Well, in this hole, I don't have a face to choose. There is no face to choose for the hole. But what we do have is the option of through pocket chain. This is a through pocket chain. So all I have to do is click on that and click on the bottom edge of that pocket. When I click on the bottom edge, it automatically picks that chain. Plus, it also adds what the value is where I pick that chain, the minus 24 millimeters. Excellent. Now, one more thing, however, I like it when it goes through that chain, through that open pocket, to go a little past that surface over there. So let's go back into Modify. I'll click on Modify over here. And we have here the option of Through Pocket Delta. I just want to go an extra millimeter, not 10 millimeters, but 1 millimeter into the part, and you can see exactly according to the arrow what's going on over there. Let's run a simulation again in the exact same way I ran the previous simulation, and we'll note the following. It machines exactly the way it did before, leaving those islands, but note this area over here, you can see that it did the hole, plus you can see the excess material at the bottom where it passed the actual part by 1 millimeter. We can also see that in this area over here, it now machined this top surface as well. So you can see there are all different types of ways we can manipulate our areas that we want to machine inside pocket recognition. We don't always have to take the entire part. We can even work on individual faces. I've known people actually to take this operation for regular pockets where they only want to do one pocket, and they'll click on that face and it'll automatically recognize everything that's on that pocket. And it actually works very nicely. Now, let's start now with our second part. Now, the second part that I'm going to load is a much smaller part. Now, this particular part, if we take a look at it, this actually has areas that are really small. For example, if I were to touch this edge, the width of this edge over there is only 3.1 millimeters. We have areas that are even smaller than that as well, going into these areas as well. So for this, try to also imagine a part like this that has many of these type of slots or small pockets, and this is very typical in the aerodynamics areas where we have different types of electronic housings that use these types of. This is basically an electronic housing that many people may work on it sometimes, and when everyone knows that. Working on something like this, you can have you need to do several different pocket operations or profile operations to get all of these down, and sometimes it makes it also very hard to pick. So let's see exactly how I can do this using the option of pocket recognition. Okay, we'll start our recognition operation of pocket recognition, and just as in the previous part, I'll choose my geometry, and this time I'll just take the entire solid body, and I'm not going to deal with even the minimum diameter because everything here is smaller than 10 millimeters. So I'm just going to click on this surface over here. As it's checking the entire part, we'll see every single surface that was chosen over here. And you can see again the list of every single surface as shown over here. That's all I need to do. Okay, next I'm going to choose my tool. The tool that I'm going to start out with, I want to start out with a 3 millimeter end mill. Well, let me go to my, instead of starting to look for it, I'm just going to go into my diameter value over here and change it. I want to see everything that's from 0 to 3. Okay, I see I have a 3 millimeter end mill over here. No problem, I'll choose that tool. My levels, again, there's nothing for me to do over here. I just have my step down. If I want, I can change it, leave it the way it is. Everyone knows exactly more or less what they would like to work at. And in my technology, exactly the way I have it in every single pocket operation. Okay, let me just change if I want to have open pocket, strategy, approach from the outside. Let me go back to my technology, and I want to leave my wall offset at 0.2 millimeters. Okay, let's run our simulation. And we'll do it using Solid Verify. And as you can see, it mills out that entire area, but if you remember that slot I pointed out to you, it could not go into that area itself. There are other areas that's not able to be machined because the tool was too large. So what we'll do is very simple. We'll go into operation and just do save and copy, creating a new operation. We're going to go and take a smaller end mill, and I'd like to use a 1.5 millimeter end mill. So what I'm going to do is, again, use my filter over here. And you can see we have an end mill over here that's 1.5 millimeters. That's the end mill I would like to use. My levels, leave that the same. If I want, I can change that to say 0.5. Everyone the way they want to do it. My technology, rest material chamfer. we're going to have that at rest. And my previous tool diameter was 3 millimeters with a 0.2 millimeter wall offset. We'll calculate that. Let's run our simulation. Again, we'll use Solid Verify to run the simulation. And as you can see, it's only working in the areas that the previous end mill could not work in, such as this area over here, going into this area over here as well. Several different areas where the previous end mill was not able to work in, even clearing out some of these corners. Now, next, I'd even like to start working on a finish operation. And the finish operation, I just want to do on the walls itself. So we'll go and click on, again, Save and Copy. And just for argument's sake for a moment, I'm going to use the exact same end mill to do my finish operation. If I go into my technology, I'm going to get rid of the option of none, of rest, put it back to none, put my wall offset at 0 as well as my island offset at 0 as well. And I'm going to click on the option of finish, but also use the option of wall finish only. Wall finish only means it'll work only on the walls themselves. Let's run our simulation. And when I run my simulation, we'll take a look at the tool path, this time just the tool path itself. And you'll see that the tool path is exactly only on the walls all around the part. Now, you'll note that there are areas still that end mill could not work in, such as this area over here. So what I'm going to do is, again, I can go down even further with more end mills, even smaller end mills. And this is very common in parts like this. And note, picking the geometry was simple. All I did was pick the entire part, and I'm just going down one step at a time. Now I'm taking my next end mill. Again, I'll select my new end mill. Let's show me all my small end mills, and I'm going to use an end mill that's 0.75 millimeters. Really small end mill. Okay? My levels, let's have this go down at every 0.2 millimeters, 0.1. Everyone knows exactly the way they work. I'm not going to get picky about it right now. And in my technology, all I'm going to do is change the rest material to rest and put in the value of the previous end mill, which is 1.5. And my previous wall offset was 0. Let's run our simulation. And this time, you'll see that the tool path is exactly only in the areas where it is needed. Take a look at this area over here. You see it worked exactly in those areas as well. This area over here may have needed even a smaller end mill, so I can use even a smaller end mill over there as well, if needed. And I can go down further and further, but note, picking the geometries in this particular case was simple. I only picked it once, and I just went down every single time to a different end mill, and actually finishing off the part this way. And this is very useful when having these large electronic components with these small slots inside the parts themselves, with all different types of steps in here as well. All of that can be done very easily using the option of pocket recognition. So let's just wind down and see exactly what we saw over here. First, as you saw, we saw this part over here being machined from the beginning, starting all the entire pocket operation, using first our roughing operations over here, let me get rid of that, using our roughing operation inside over there, then going down further to the next area, roughing those out wherever that previous one could not work, then doing a finish on the walls, and then finishing off in the areas where the previous operation could not work. That's what we saw in this part. And also in the previous part, just a quick reminder, what we also saw over here was besides switching of the end molds, we also saw exactly how we deal with fillets, how we can choose different surfaces to work on different areas only instead of the entire part. So how we can completely manipulate this to work exactly the where and how we want to work on the part itself. Okay, as I said, this will be approximately a webinar of about a half hour, which is exactly what it was. I hope you found it interesting. Of course, the webinar will be posted, the recorded webinar will be posted on our site sometime tomorrow, and the parts will be available this week on this webinar. Okay, I'd like to thank everyone for joining us in the webinar itself, and have a great weekend, and see you in our next webinar.